Now let us solve few examples based on the continuity. Here is the first question, that is, discuss the continuity of following function at x equal to 2. Here we see that the function is defined as f of x is equal to x square if x is not equal to 2, and f of x is equal to x plus 2 if x is equal to 2. So we will encounter this specific way of defining a function many times in this chapter. So let us understand what does this mean. First of all, the question is asking about checking the continuity at point x equal to 2. Alright, so if we quickly recall the definition of the continuity, if we want the function to be continuous, then the limit of the function as x tends to 2 must be equal to the value of the function at x equal to 2. Alright, so if we get this particular fact, then we would declare that the function is continuous at x equal to 2. So let us check what happens. Now to find the limit, that is when x tends to 2, it means that x is not equal to 2, isn't it? It is in process of becoming closer and closer to 2. So therefore, when we want to find out the limit of the function as x tends to 2, it means that basically x is not equal to 2. So therefore, when x is not equal to 2, we will use the first definition of the function, that is we have to basically find out the limit of x square, right? And we know that this is a simple polynomial, so to evaluate the limit we will substitute x is equal to 2. So therefore ultimately we will get this particular limit as equal to 4, right? Now the right hand side is f of 2, that is we have to find the value of the function when x is equal to 2. Now if you check, when x is equal to 2, the function is defined as x plus 2. So therefore f of 2 will be nothing but 2 plus 2, which once again turns out to be 4. So we observe that the limiting value of the function as x tends to 2 is same as the actual value of the function at x equal to 2. So therefore we say that the function is continuous at x equal to 2. So based on the definition, we say that function is continuous at x equal to 2, which is the final answer. Right, let's move ahead and see another question. Test if the following function is continuous at x equal to 0. Alright. So here if we see, the function is defined in slightly different way as compared to the previous question. Now here we have to check the continuity at x equal to 0, and if you see, the function is defined by partitioning the domain in 3 parts, that is either x is less than 0, x equal to 0, or x greater than 0. And we can see 3 different expressions for 3 different parts of the domain of this function, right? Now once again, if we want to recall the definition of continuity, we must have limit of the function as x tends to 0 must be equal to the value of the function at x equal to 0, because x equal to 0 is the point to check. But when we say that x tends to 0, it can do so in 2 different ways, that is from left hand side as well as right hand side. So therefore we must first get the limit of the function as x tends to 0 minus, that is from left side. This must be equal to right hand side limit of the function, that is limit of f of x as x tends to 0 plus, and both of these in turn should be equal to the value of the function at x equal to 0, correct? And this we have already seen in the definition also. So if we talk about the LHL, right, that is nothing but when x is less than 0. So limit of the function when x tends to 0 from left side will be nothing but the evaluation of 3x plus 2. So we can do that directly now as the definitions are in front of us. So that gives us 3 into 0 plus 2, which is nothing but equal to 0 plus 2, so that is equal to 2, right? Now let's see what happens if we try to calculate the RHL, that is the right hand side limit of the function, that is when x is greater than 0. Now in that case we have to use this particular definition, that is x minus 1. So as x tends to 0, the limit of the function is the limit of x minus 1, so that is 0 minus 1, which is minus 1. So here we observe that the left hand limit and right hand limit are not equal to each other. So that means that the limit of the function itself does not exist as x tends to 0. So therefore there is no question of that limit being equal to f of 0. So therefore the answer is that the function is discontinuous at the given point x equal to 0. Alright, so in this way we check the continuity of a function.